Hi, it's Ben the Audi guy again. Brian and Edward have tasked me with another video, so I hope you like this one as well. Today I'd like to talk to you about parametric surfaces. If you recall, earlier we talked about parametric curves. This is a similar idea, except for now these are surfaces, which are two-dimensional objects. Let's start with a quick definition. A parameterization of a surface S is of the form x of u v, comma y of u v, comma z of u v. Where u and v are in some domain, D. Let's start with some examples. Let's first of all consider the case like this, where we have u cosine v, comma u sine v, comma 2. Well, let's put some limits on what u and v can be. Let's have u range from 0 to 1. And let's have v range from 0 to 2 pi. Okay. So first of all, we can notice that everything is at 2, the height 2. So all the points in this surface have z value equal to 2. Furthermore, we can recall that x squared plus y squared is equal to u squared, which is a disk. And furthermore, u goes from 0 to 1, so it's a solid disk. So let's see if we can make a disk of radius 1. So remember, everything's at height 2, and I want to come out. And this is a filled-in disk of radius 1 at height 2. Thereabouts. Now let's do a second example. Let's do u pi v. And let's let u and v be any real number. Okay. So now we've noticed that this entire surface must lie at y equals pi. But there's no restrictions on u or v, so that means we get the entire plane of y equals pi. So let's see if we can draw that. So here's the point 0, 0, pi, or thereabouts, and we have a plane that hopefully I can draw. And this continues out indefinitely because there's no limitations on u and v. And one more quick example. how about u, v, and u squared plus v squared? Notice that x squared plus y squared is equal to z. This is a paraboloid. So we can just draw a regular paraboloid. I should note that, again, I want u and v to just be an r. If the domain is not noted, normally it's the most natural thing, which is u and v over the entire possible domain. So we have a paraboloid. So it looks something like that. Now we can also look at a reparameterization of this surface, and we want to use what's called cylindrical coordinates. So I'm going to have u, or in this case x, be r cosine theta, y to be r sine theta, and finally z is just r squared. Now here I do have to put some restrictions on the domain. I'm going to have theta go from 0 to 2 pi, and I want r to be non-negative. So just like when we had parametric curves, we have more than one possible parameterization for any given surface.